Hello everyone, welcome to the lecture series of computer networks. I am Harsh Khattar, working as assistant professor in Department of Computer Science at KIET Group of Institutions, Ghaziabad. In our last lecture, I was discussing about the CSMA methods. Today, we will continue with these methods with some latest versions. As we have already seen, there are various methods like controlled access protocols, channelization protocols and random access protocols. In random access, the basics ones are start from the CSMA, and this CSMA has three basic tendencies. Like in a network, if I want to send a data to my friend, so in this case first thing is I am sensing the network is busy or not. Means I am talking about the persistent methods which we have discussed in last class. So, today we are continuing our lecture from the same persistent methods for 1 minute, and then we will switch to the latest ones, means CSMA CD and CSMA CA, because these persistent methods are the first step towards CSMA CD and CSMA CA. In this diagram you can see that directly we are sensing, continuously sensing the network, either a network is free or not. If as a sender I sense a network is free, I will consume a network and start transmitting my data. If my network is busy, if you will see here, there is a arrow which is redirecting towards the decision box, that if a network is busy, continuously it is sensing the data. So, this is my one persistent, means always sensing method every time. This is the same scenario if I am standing outside the class, and if there is no faculty in the class, I am going inside to the class and start taking my lecture. But if a faculty is inside the room, I am continuously standing outside the room and waiting for the faculty member who is inside the room to come out, and whenever the faculty will come out from the class, I will go inside and start my data transfer. The other method was the non-persistent. Non-persistent means I am waiting in a network, waiting for the network to be free, and I am checking the network at random time. What is the example for this? A faculty is in the class, I am going outside the class, I have seen from the window, yes, someone is there inside the room. So, I am going to my cabin, back to my cabin, or might be the canteen, and after a cup of tea I am coming back after 10 minutes and seeing, yes, now the faculty is there or not, still the faculty is there. So, again I am moving here and there, after 2 minutes I am checking the class, yes, is there any faculty? No, now I am using the network. It means we do not have a specific time period to check the room, randomly I am going there. So, this is the non-persistent method. And another one is the regular interval, like I know that my lecture will be from 10 to 11. So, at 11 I left the class, now 11 to 12 another lecture. If I want to take a lecture, if I am going there at 11:45, it means already the faculty is there. If I want to take one extra lecture, I have to go at 12, because there is a specific time period. So, this time period is represented by P. P means a specific time, a specific amount. If I am moving outside the class and seeing, yes, one faculty is there, so I know there is a specific time interval. After 50 minutes I will go and check, yes, is there any faculty or not. If there is no faculty, I am going inside the class and taking a lecture. Similarly, I am sensing the network after regular interval and I am checking, yes, is there anybody else in the network who is occupying the bandwidth or channel? No, then I am taking the channel and start transmitting the data to the receiver end. So, this is what we have discussed in the last class about the persistent methods or variants of CSMA. Now, there is one issue. In this variant, we are doing the prior task, means before sending the data, before transmitting the data, my focus is on the network or the channel is available or not. If a channel is available, I am assuming, yes, now the channel is free and I can accommodate my data on the channel for the transmission purpose. But what will happen if at a same time, means there are two doors of a class, one faculty is standing on door 1, another faculty is standing at door 2, and both are sensing now the faculty is no faculty is there inside the class. So, maybe there is a scenario when both the faculty members, faculty 2 and faculty 3 are moving inside the classroom at the same time, because both have sensed that there is no other data transfer in the network. So, both the users are moving inside the network at the same time. Then what will happen? Means the collision situation will be there. Let us see this scenario of a network. Suppose in a particular network on a channel there are 4 users, user A, B, C and D. If A wants to send a data, what A will do? A will first sense that the network is available or not, means any of these methods can be used for this. So, this is a step 0, which is CSMA persistent method, either 1 non-persistent or P persistent. From any of the method, A will sense the channel and check that channel is available or not. If the channel is available, what A will do? A will start transmitting the data. Say on a same time or from the last few minutes, C is also trying that the channel will be free and C will start sending the data. Might be the B was the one who was already occupying the channel. So, B's transmission is over and A and C together sending the data. What will happen? So, this is an important scenario. Might be you will see these type of questions in the competitive exam. Say if A sends and the channel is free, A started data transmission, this is number 1. C sends, channel is free, C started data transmission, number 2. So, what will happen if both the conditions are true? In this case, what is the outcome of this? Means both are starting sending the data and there is a state of collision. Both the packets at a same time, if in a channel 2 users are sending the packets, it means there are chances of collision, and if the collision will happen, what will happen? Means both the packet will lose. So, what is the solution for this? I hope you all are able to understand what is the scenario and what is the issue in this. Okay, let me give one example for this. This is the same scenario that with the time, means you can treat this vertical axis as a time. If we are going downwards, the time will increase. In this case, the A sense that the network is free, the channel is free. A started data transmission. So, this is a data transmitted, this one. There is a packet or the frame which is moving like this, and yes, the data is transmitting, A is transmitting this, and here C start transmitting the data. So, at one point where at the channel both the packets will reach, this is a point of collision where the collision occurs. So, here this type of issue is making the collision state and our data, the packet will lose. So, in this scenario what we will do? Do the network shows something to the A that there is a packet collision, the packet which you have sent over the channel was now collide. Is there any sort of notification which is reaching towards the A? No. Similar case with the C, if C started data transmission, if a packet collides, damage or loss, do this node C or A will receive any sort of notification of collision? No. So, what will happen? They are assuming the data is successfully transferred, and which is not like this. If I am sending a message to my friend that I am coming to your home at 5 p.m. and I am assuring yes, if I have sent the message will be received by the person, but I have not seen on the WhatsApp, yes, there is a double tick or single tick, and at 5:30 when I reached there, I was seeing at my friend's door there is a lock. Then I have seen my WhatsApp, it was a single tick because my mobile data was off. So, how I will recognize this thing? So, there is some sort of mechanism which acknowledges me that my data is transferred or not. In a same manner, we can see here, if A is sending a packet, or data, or C is sending a data, and if in between there is some mishappening and collision occurs, then at least A or C must aware about this, that the packet is reached or not. So, for this we have another method. Okay? So, this is a state of collision when on a single channel multiple users are sending their data. So, this was the issue in the persistent one, because it was the prior approach, but once the data is on the channel, they are least bother about the network. So, here we have another method, which is the CSMA CD, and CSMA CD will give the answers of multiple questions. What are the questions? What will happen if the collision is there? If a collision occurs, what will happen? What your mechanism is doing? Do we go for the next attempt? If one collision is there, what we are trying to do? If one sending fail, then do we send the another message? So, this is one question. So, the answer is yes, we can send it again. We have the multiple attempts, but how many attempts? Is there any limit for the attempt? So, yes, we have a limit for the attempt as well. What will we will do if A and C sends a packet? A and C, they are sending the packet again together, and again the collision will occur. Then what will happen? So, if again collision is there between the A and C, so they are sending the packet, and here it is a state of collision. Third time they are again sending the message. Generally we have seen this, if your friend is calling you and there is a network issue, then you are saying, okay, I am unable to listen to you, so call me again. From their end your friend is calling you, from this side you are calling your friend, and both the end you are listening this, yes, the network is busy, or the person is busy, or the person is on another call like this. So, what it means? Again and again the frequency of both receiver and sender are same, or both the senders A and C are same. So, again there are chances of collision. So, what will happen with this? Do we have some sort of notification signal? Yes, because of this collision there is an error in the packet, or your channel is not appropriate, the working of the channel is not appropriate. So, the answers of these questions are there in this CSMA CD. Carrier sense multiple axis collision detection means persistent model was there for prior to the transmission. Now, collision detection says there is a mechanism if you are sending a data and the packet or the frame or the data stream collides. In this case, you are receiving a signal. What is the approach for this? Just focus on these lines, that the method is same. There is some entity which sense or listen whether the shared channel for transmission is busy or not, means the persistent approach. And if the channel is free, only then transmission is possible. If the channel is busy, then deferred transmission, means it will not allow to transmit the packet because the channel is busy. Detects collision by sensing the transmission. So, how it can be possible? What is the answer of the previous question, or what are the answers? Do we have a single answer for 5 questions which we have seen earlier, or we have multiple answers? So, we have multiple answers. We have specific rules, a protocol to follow to answer the previous questions. Like first, if a system detects there is a collision, before this we have sensed the medium, we are checking, yes, if the channel is free then the transmission is allowed, otherwise we need to wait. If there is chance of collision, what will happen? Now, the system says the station stops transmitting. Further, once I get to know, yes, there is a collision state, there is a traffic, a huge heavy traffic on the road, there is a truck who is stuck between, then I won't go this particular lane. It means I am stopping my transmission. This is a step number 1. Step number 2, sends a jam signal. Generally, we have seen on the Google map there is a red signal, yes, there is a huge traffic on this particular lane. In a same manner, in a network, they will broadcast the jam signal. Yes, you means your node A, your node C, both are notified by the jam signal that don't send further messages because there is a jam, there is a collision state. and waits for a random time interval before retransmission. After some time, means might be after 10 minutes the jam will be clear and some traffic police person will come and they will clean the road and there is a smooth road. So, there is no jam or traffic. So, in such manner we can assume in a network if there is any collision after few time, after few minutes or seconds, the network will be clear and again you can send the data smoothly. So, what is that particular time? We will see in the coming slides. So, I hope this scenario is clear to you. This is a working of CSMA CD. For more details, just have a look to this. This is the algorithm. If there is a question, what is the approach or algorithm of CSMA CD, then there are basically the 3 stages. Stage 1, first thing is to sense either a network is free or not. If the network is free, then transmit the data. Now, your task is not yet done. The data is transmitted over the network, but there may be a chances of collision. If collision happens, then what is a collision resolution? How you can resolve this state or how your network or channel will resolve it. So, there is a separate algorithm which is highlighted here, collision resolution algorithm. So, these are the 3 main stages where the steps are: first, if the frame is ready, if I am ready to send my data or frame, then I will sense the channel is ideal or not. If the channel is busy, not ideal, means I have to wait in the persistent mode. Then if a channel is ideal, I will start transmitting the data, and side by side I need to sense whether there is a chance of collision or not. If there is any chance of collision, if the collision detected, then we have to switch to the second algorithm where we start jamming signal. So, we will see in the next slide. Then the station resets itself and retransmission counter is generated, means initially I am sending my packet. So, my variable k means the retransmission counter is 0. If one collision happens, I will retransmit the packet. So, counter is equal to +1. Now, the k value is 0 plus 1, 1. Suppose again there is a collision, then k will increment it by 1. Now, the value of k is 2. Similarly, 3, 4, 5. If there are 5 collisions of same packet, then the k value is 5. This k value is with respect to one frame. If there are 2 collisions and of different frames, then the value of k will be 1, not 2. K represents how many times you are retransmitting the same packet, okay? Not in the network how many packets are collide, no. We will see in the next slide, this one. So, this is the algorithm, this is the magnifying part of this. What is a collision resolution algorithm? So, again there are 3 stages. Number 1, send the jam signal, then retransmission of the data. We will retransmit it by incrementing the counter and then waiting time. When you will retransmit it, if at the same time once you detect the collision, again you are sending the packet, means already the network is choked and you are sending the packet. So, it will take more time. If you will leave the network for few amount of time, then the traffic will be smooth and you can send the data appropriately on the network and receiver will receive it. So, this is basically the collision resolution algorithm where the station continues the transmission of the current frame, and if there is any collision, then the jam signal will be sent once the collision is detected. Once the jam signal is identified by A and C nodes, they will do one thing, they will increment their counter. Suppose A and C both are the nodes and they send the packet and there is a collision. So, what A will do? A will send the packet again by incrementing its counter 1. Similarly, C will increment its counter, the retransmission counter k by 1. Okay? And in this manner, if there is a maximum number of retransmission, for example, I am saying the maximum number of retransmission is 10. So, already 10 times I have sent the same packet. So, I have reached to a particular threshold, means my transmission will be abort, no further. Suppose a faculty is waiting for the 8 lectures. So, in a day there are only 8 lectures. So, why I am using the 9th one? So, now for a day I abort the class, next day I will start with the 0 like this. Otherwise, station waits for the back off period. What is the meaning of back off period? That particular time. As I have mentioned in a network, if collision occurs, then you have to wait for a specific time. What is this time? This is a very important 2-mark question. If there is a collision, then after how many minutes, seconds or milliseconds, or after how much amount of time you are resending, retransmitting the data. This is known as the back off time, and the algorithm to identify this timing is back off algorithm. So, back off period is the waiting period for the station involved in the collision, i.e., that is, we can say, for how much time the station would wait for retransmit. You can also assume this as a waiting time or back off time. Okay? So, this is 2-mark question. This is a flow chart what I have explained in the steps. You can see the same thing here. This is a retransmission counter. These diagrams are taken from the Forozen book. The reference is given here. You can also refer the chapter number 12 of Forozen book of data communication and networking. You will get the same diagram. This is one question. Generally, they ask what should be the time interval? What should be the frame size? This question is also from the same book, Forozen. So, you can just go through for this because there is an important concept. If I am transmitting a data, so here the data speed which is mentioned here and the propagation time. So, whatever the time is used here, it should be doubled to check, because if I am sending a packet, the chances is at the initial level there is a collision, or at the mid or at the end. If my first bit collides at the end point, at the receiver end, at this point. So, if there is a collision at that end percent, means 99.99% data is transferred or reached to this, means my first bit reached at this point, 99.99% area is covered already. This is a distance and only this point is left, and if the collision occurs, in this case you need a jam signal back at this point before the sending of the data. So, in this case, before the last bit of transmission, you need a jam signal here or the acknowledgement of collision. So, in this case, it should be considered as the double of the propagation time. So, that is why there is a formula mentioned here. There is a formula like the total frame transmission time should be the double of the propagation time, and the propagation time mentioned is this. So, it should be this, and based on the data transfer speed, which is 10 Mbps, we can calculate it. So, the minimum size is 64 bytes, or when we convert it into the bits, so 512 bits. This is the minimum size which is mentioned here. So, this is an important one, that is why I have added it in the slides. But there is one issue with the CSMA CD. What is the issue? The ratio of retransmission is more because collision is more. If I increase the number of users, the collision will be more. So, what is the solution for this? The solution is collision avoidance. So, we have one rule that we can avoid the collision. How we can avoid? First, we can sense the medium and send a packet. Yes, I am sending the data, or there is one person who is keeping track. Yes, currently the computer networks faculty is in the class. Don't go inside. If you go inside, there is a chances of collision. So, this is a better approach than the CSMA CD. What the approach says? Approach says that we have ready to send and clear to send packets. Ready to send means if my frame is ready, I am saying I am ready to send the data, and there is one access point which says yes, the network is clear to send, now you can send the data. So, this will help in the collision avoidance. Similarly, in a network there is a simplest way in this. What is this? Let us have a look to this algorithm. If the frame is ready, the transmission state in text either channel is free or not, means this is a persistent one. Another one is this wait for interframe and transmit. What is this interframe? Interframe means if you have sensed a particular channel, it is free or not. In this case, you are giving some sort of amount of time, so that any other person is also sending this ready to send message or not, or clear to send message to the network that yes, it is better to wait for a time instead of the collision. So, this is the approach here, that before sending a data, we first go through the network through the ready to send and clear to send packets. So, this is the algorithm. Again, this algorithm is from the same Forogen, the reference is given here, you can refer this. Yes, there are some advantages. Obviously, it is clear the advantage of CSMA CD is basically that here we are talking about it prevents the collision. Yes, you can treat this as a CSMA CA. So, here it prevents the collision, but it take more time. So, the time management is more. Yes, it avoids the collision, but we have to wait or engage the other nodes, because we are sending the clear to send and ready to send packets, and these messages are again going in the network, which consumes some of the bandwidth. So, this is the diagram, this is what I have explained. So, again you can refer the Forogen for this. Yes, this is a summary for the university exam. You can see the questions like this. This is a very important question. Elaborate the back of algorithm or the role of inference space. Sometimes it is interframe gap is also interframe gap, and sometimes it is interframe space. Again, why CSMA is required, CSMA CA and CSMA CD difference is there. So, now this is a question for you. If you are making your own system, what you will prefer, CSMA CD or CSMA CA. So, this is all about the today's class. In next, we will talk about the framing. Thank you.